12, very similar to chapters 10 and 11. We're studying a hypothesis. We're trying to see if things are different or the same or bigger or smaller, whatever. But analysis of variance is going to help us figure out things if we have uneven samples or if we have more than one. So say I had 5 classes of statistics to analyze, and I wanted to see, is there a difference in how all of you did, or is there not a difference? Well, I can do the hypothesis testing that we just learned, but that's only for 2 things, for either population and sample or 2 samples. But I want to deal with if I have a lot. So we use something called an F statistic. We need to determine whether or not we have 2 equal proportions or variances of 2 populations are equal. Analysis of variance is also, that's ANOVA, and it comes up with a table, and I can very quickly go in and see what my F would be. Now we're going to just do an introduction to this, and we'll continue it on the next class. So ANOVA, or the F distribution, for Sir Ronald Fisher, one of the founders of modern-day statistics. This F statistic is used to test whether 2 samples from populations have equal variances. We can use several populations, several means, and analyze it simultaneously and see if there's an overall difference. So we have a family of F distributions similar to those that we talked about before, but you see it's a little shaped differently. We have, there we go, F distribution is always continuous data. F cannot be negative, so when you have your cutoff, it's always going to be positive, and your cutoff is going to be determined not by looking at the table that I gave you, but it's going to be looking in the back of the book using your degrees of freedom in the numerator and the denominator, which we'll talk about. So what we'll be analyzing is if the variances are equal for this one. And what I do to figure out what my F is, I have the standard deviation squared, which is the variance, of the first one divided by the standard deviation squared of the second one. So for this one, I have a limo service that offers from City Hall in Toledo to the airport in Detroit. The president of the company is considering 2 different routes. We have one on US 25 and one on I-75. I want to study all the times, and these are all the times that I had. And one of the things that F is, or the ANOVA is good for, is that I can have unequal variances, or unequal ends, unequal groups. So I don't have to study 10 in this group, 10 in this group, and try to compare. So what they want to know, using the 0.1 significance level, is there a difference in the variation in the driving times for the 2 routes? So we're looking at how much each one of these varies from the mean. This is a little different than what we've done. But the hypothesis is they're either the same or they're not the same. The significance level they give you in the problem, 0.05. The F distribution is what we're going to use. And what they've done here, the decision rule, in the denominator and in the numerator, we're figuring out what the degrees of freedom is going to be for each one. Degrees of freedom for the first one is going to be the 7 minus 1, which is 6, and the other one's going to be the 8 minus 1, which is 7. And where they intersect is going to tell me what that cutoff is. So every cutoff is going to be different. It's all going to be dependent on this. Now when we talk about the equal variances one, it's the n minus 1 for the first one, n minus 1 for the second one. But we're going to talk about ANOVA, where it's going to be the number of groups, degrees of freedom, and then the means, degrees of freedom. So then I calculate my F statistic, and I'm going to show you how to do this in ANOVA, or ANOVA and Excel, which is so much easier than how you have to do it by hand. But this one's an easy calculation. I'm just figuring out what the standard deviation and variance would be. They've given me the X bar, which again is going to be the mean, and I come up with a mean for each one. My standard deviation, I'm filling out that table where I'm subtracting each X from the mean, squaring it, adding them all up. This is back from the other chapters. And bless you, dividing by n minus 1, taking the square root, and then I come up with this value and this value. These are the 2 standard deviations. I want to compare these 2 standard deviations. So for the F statistic calculation, all you're doing is plugging these in, but remember you're squaring it, so it makes it the variance. And I come up with 4.23. Back here, we said that the cutoff was 2.87. We're using the same theory as we did with the other ones. So if it can click for me, click. Okay, it's not wanting to work now. So it worked all this time, now it's not going to work at all. So what I want to do is figure out, did it go past that critical value, that cutoff point that I figured out in the back of the book? And the 4.23, yeah, it does go past it. Remember, your F is not going to be negative. It's always going to be positive, so you're just worried about if it's bigger than this F value that I found in the back. So we can conclude there is a difference in the variation of times that they're traveling. We're not seeing which one's faster or shorter or whatever. Now I want to compare different groups or populations. So let me get this up here. You're going to have a null hypothesis, alternate hypothesis, just like you had before. You come up with your test statistic, that's an F. Your decision rule, you look in the back of the book. Again, we'll go through that. So what we're doing here is, and this shows to the K, which means however many groups I have. So I have 12 statistics classes. I want to figure out the average grade for each class. Well, then that K would be 12. I'm comparing it all the way out. I'm not really looking at these individual groups as much. I'm just looking to see if there's an overall difference. Then I can go back as a researcher and go, okay, Dr. Manton's first class made highest grade, then Dr. Flanagan's third class, and then whatever. Then I can make conclusions about other stuff. But right now I just want to know if there's an overall difference. So my hypothesis is going to be either they're all equal or they're not equal. It's always going to be that equal or not equal. Let's see. For my degrees of freedom and how I'm going to calculate stuff in the back, or figure out the cutoffs in the back, I'm going to take K minus 1, that's the number of groups that I have, minus 1. And then I'm going to take the N minus the number of groups that I have, and that figures out what it's going to be in the back. Again, we're just kind of doing a quick overview so you can get some homework started and we can go through problems on Friday. So for the first one, it's K minus 1, that's the number of groups that you have, minus 1. And for the denominator, it's going to be N minus K. So if I have 40 people that I surveyed, then it's going to be 40 minus however many groups that I have. I had 5 groups, 40 minus 5. And to figure out what my F statistic is going to be, SST divided by the K minus 1, SSE divided by the N minus K. Right now this is completely foreign to you. You have no idea what it means, but there's a table that you fill out that makes it a lot easier. So let's go through an example, and then you'll at least have a little bit there to start the homework. So Joyce Coleman manages a regional financial center, which is to compare productivity of each one of the 3 employees. 4 days are randomly selected, and the number of customers served by each employee is recorded, and the results are following. 3 different people, all their results. You grab the same number in each group, so it's a little bit easier to calculate. So what would my K be? How many groups do I have? 3, so my degrees of freedom for my groups would be what? 2, it's just 3 minus 1. And then how many do I have total? 12, and so what would my other one be? It's going to be N minus the K. 12 minus 3. So, okay, that's just so you're not getting it confused, because that was always the confusing part to me, is to figure out what's the cutoff. Here's one where they have different sizes of the N for each group. So here they want to compare these different airlines. This is going to be, they ask them questions on ticketing, boarding, in-flight service, etc. 25 questions were offered a range of possible answers from excellent to poor. Here are the responses that were totaled, and they want to compare these two. They want to see, is there a difference in the mean satisfaction among these 4 airlines? Right now I don't care which one's the better one, which one's the worst. I just want to know, is there a difference? So my null hypothesis would be that they're all the same, and I like how they've labeled these, so then you don't have 1, 2, 3, and 4, and you're looking back. I can very quickly see which one of these it belongs to. And then the H1, this is fine to put, or you can put slashes, just rewrite this. The means are not equal, or the means are equal. Basically, that's it. And I want to reject at this point, which means I need to figure out what K minus 1 is and N minus K is. My level of significance, they tell you in the problem. we're in chapter 12 and we have more than 2 groups, so we're dealing with an F statistic. So I want to figure out what my cutoff is going to be. The denominator is going to be this one, the 22 minus 4. I get 22 because I had 22 total out of all 4 groups. I had 4 groups, 22 minus 4 is 18. For the first one, for the denominator, it's going to be 4 minus 1. I had 4 groups, 4 minus 1 is going to be 3. And I find where there's 2 things intersect, and I get 5.09. I'll pull that up for you. Now I'm going to complete this table. So we're just going to do a little introduction so you are familiar with it, even though it's really confusing right now, and that's okay. I had to find F statistic back here. So here are formulas for each one of these. The SS total, this is what I'm going to do. I'm going to make a table. This is why Excel is your best friend for these problems, because this takes forever. 4, 5, 6 pages of doing this, especially if you have a lot of data. So for the first one, the SS total, that's where this one is right here. I'm going to try to write this again. Work. Does not want to work. Okay. I don't know what I did. Okay, so for this one, the SST, the SS total, it's going to be adding up every one of them, the X minus the grand mean squared. For the SSE, it's going to be each one of them minus their treatment, or each one of their means, and squaring them and adding them up. So it's going to take working through these problems, but I just want you to see the table first. And then you're just completing this table. These two will add up to the SS total. So if, for instance, on the test, if I give you this number right here, this number right here, this number right here, that you would be able to plug in the other ones, because you see these two are just added up. These two should add up the same way. And then figuring out, once you fill in all this, again, we'll go through an example on Friday, then I'm able to figure out what my F is. Now when we do this in Excel, like I said, it's a lot easier, so we'll use this example in Excel. Here's the example of the grand mean. I've taken all of these and divided by the 22 that I have, and I come up with this as my grand mean. So I'm taking each one of these, subtracting the grand mean, adding them up, squaring them, adding them up. So this is an example. Again, why Excel is so much better. And then let's say I've done all this and I understand what I'm doing. I come up with the F of 8.99. If you get 8.99 in anything, it's definitely rejecting your null. There's never going to be a cutoff that's going to be that big. 5.09 was the critical value. 8.99 is what we came up with. So yeah, there is a difference in how all of these ranked. Then I can go back later as a researcher and determine which one was better. We're not going to worry with this one. So that gives you a little bit of an introduction to chapter 12. So now let's, with your group 2 or 3, let's start to go through some of these homework problems for chapter 11. Are there any in chapter 10 that you had a question about?